quality is the degree to which set of inherent characteristics fulfill the requirement. So essentially, a stakeholder has requirements, and to the degree to which we fulfill those requirements defines the quality for the customer. So as per the quality gurus, Philip Crosby, conformance to the requirements of the customer is what quality is. Edward Deming, he says, predictability, predictable uniformity and dependability at low cost and suited to the market is the quality. And fitness for use is Joseph Juran, another quality guru or expert, says about that. He defines the quality like that. So like as a it is observed that in PMP examination at times these statements are used and they ask you, who said what. So one of the side assignment you can undertake is maybe sometime in the week you can see these Philip Crosby and what their definition of quality is. Anyway, it is already there, but in general, at high level summary paragraph kind of thing you can read maybe from Wikipedia or Google it out. That will help you because at times there will be questions, how we understand these quality gurus, which is not there in PM Bob guide. So that's even these statements you will not find in most in PM Bob guide. So that is the importance of this slide. Otherwise, we'll move on to the next slide. Otherwise, I mean, there is nothing. Otherwise, basically, that's all there is to. We have to do, read about these quality gurus before moving on to the actual project quality management. Here, in this slide, we have this slide, rather modern quality management or project quality management is essentially, it is based on ISO, that is International Organization for Standardization Quality Standard. So it essentially has 5 tenets. The 4 are in front of you. The 5th one is cost of quality, which we'll be discussing. There will be one separate slide on that. So modern quality management complements project management. Both disciplines recognize the importance of. So this is the first one is customer satisfaction. So essentially understanding, evaluating, defining and managing expectation so that the customer requirements are met. This requires a combination of conformance to requirement and fitness for use. The second one is prevention over inspection. Quality, one of the fundamental tenets of modern quality management states that quality is planned and designed and built in and not inspected in. So you always prefer prevention over inspection because cost of prevention is generally much lesser than the cost of correcting. So there is an obvious reason to that. Then the continuous improvement. This is it is the PDCA cycle is the basis for quality improvement. And if you remember this continuous improvement or PDCA cycle this was defined by Shewhart and modified by Deming. This is also Plan, Do, Check, Act. Essentially, is also one of the tenet or basis of the IPEC that we keep on seeing, right? It's iterative in nature. IPEC we talk about initiation, planning, executing, monitoring and control, and closing. So, so this is. I told you in the first few sessions that PDCA is the basis of IPEC, the cycle or iterative nature for many process that are being performed. They also use that, and hence you can always do the continuous improvement. This is also called at times Kaizen principle also, but the fundamental tenet is PDCA. Then the next one is management responsibility. So everything, I mean, quality requirement or quality importance comes from the top. So success requires the participation of all members of the project team, but remains the largely the responsibility of management to provide the resources needed to succeed. Because just giving responsibility is not sufficient to the project team. The management needs to provide the resources to perform these quality related activities. Then the cost of quality, the fifth one, which is not in front of you, but it is covered in other slides. So which we also saw that it is total cost of conformance, plus cost of non-conformance. So we'll see what are the examples of what is the cost of conformance and non-conformance in appropriate slide. So when you perform quality control, so we should be knowing differences between a few of the terms which are used in perform quality control. So it is the process of monitoring and recording the results of executing the quality activities to assess performance and recommend necessary changes. It is performed throughout the life of the project. QC or quality control requires the project manager or another qualified person to monitor and measure project results to determine whether they are up to the quality standards. So in case of non-conformance, root cause analysis is done and appropriate action is taken. So the terminology that we should be aware of is tolerances is specified range of acceptable results. So usually stakeholder has tolerances, management has tolerances, organization will have tolerances, so which is at the high level. Then there is a control limits. These are the threshold which can indicate whether the process is out of control. So usually control limits are set below the tolerance level. So let's say the tolerance level of the customer is plus or minus 15% for the cost. Then your control limits, the upper control and lower control, you can keep at plus or minus 10%, for example. So that is the tolerances and control limit thresholds. Prevention is keeping errors out of the process. Inspection is keeping errors out of the hands of the customer, which is both are important and both needs to be performed. Of course, prevention has better result because in that inspection those errors will not come out, and hence will save a lot of rework and scrap work related cost. Then attribute sampling is the result either conforms, so it is binary, either conforms or does not conform. In variable sampling, the result is rated on continuous scale that measures the degree of conformity. So these are the terms that we use in quality control. Moving on, perform quality control has following tools and techniques. Control charts, these illustrates the performance of project over time. We map the results of inspections against a chart. Outer limits are set by the customer requirements. Within them are upper and lower control limits. We are going to see the this control UCL and LCL being set in one of the subsequent slides. So in here, this slide talks about the control charts are useful in setting up upper control limit and lower control limit, which helps us in managing the customer expectations with respect to the quality requirement. Then other concept is cost of quality. So I told you that we'll have a couple of slides on just cost of quality. So this is what it is. So cost of conformance is money spent during the project to avoid quality planning, avoid failure. I mean, not avoid quality planning, avoid failure on quality planning, process control, quality control, design validation, process validation, test and evaluation, quality audits, field testing and training. So this is cost of conformance. Cost of conformance, these are the examples of cost of conformance. Cost of non-conformance is the money spent during and after the project because of failure. So rework, defect repair, additional inventory, corrective actions, warranty repair or services, complaint handling, liability, scrap, product. So this is in general. So which is more expensive? Obviously, cost of non-conformance is going to be more expensive compared to the cost of conformance. So this is more structured, is the same and with example. So cost of conformance is essentially having two components or two categories. Prevention cost, so which is essentially training, document process, using standards, equipment, time to do it right, those kind of prevention cost. Appraisal cost, so assessing, so this is building a quality product. So prevention cost is something which is built in. Whereas appraisal cost assess the quality, assess testing, inspection and restrictive testing loss. So these are the cost for appraisal cost. Then coming to cost of non-conformance, it can be categorized into two. Internal failure cost. These are the failures found by the project. So you have rework and scrap as the example of internal failure. But this is better than external failure, which will be found by the customers. So it's a liability or warranty work and loss business. That's what it will result into. So you can see that all the cost of conformance is money spent during the project to avoid failures, and this is money spent during and after the project because of failures. So obviously this is always better, but all of them will have to do. So internal failure cost, rework and scrap will obviously affect us, but this will have the bigger impact. So we have to work towards avoiding the external failure cost.